this lesson, we're going to learn how to solve systems with matrices. If you don't have a graphing calculator handy, pause and go get one. All right, we are going to learn how to rewrite linear systems with matrices, and then we're also going to use matrices to solve a linear system, and that's where we'll use the graphics calculator. Make sure you pause at those points to try it out on your own. In this first slide, we're going to take a look at what happens when we multiply a matrix equation like this. So on the left side, you'll see that I have a row highlighted and a column here. And so we're going to take row 1 times column 1. And when I take row 1 times column 1, I get 2 times x plus 3 times y. And that's going to give me the answer that is in row 1, column 1, and that's 25. And then I'm going to move this down to row 2. And when I multiply this out, I'm going to get 4x plus 5y because I'm taking 4 times x and 5 times y. And that's going to give me the answer in row 2, column 1, because I am multiplying a second row, and here I only have one column. And that equals 43. And now we've got a system of equations like we've been solving for the last few days. Now we're going to actually use our calculator to solve them. So here's that same system we have here, and we're going to call this first matrix A and the second matrix B. And in order to solve for xy, because we want to get xy all by itself, we want to be able to get rid of this. But we can't just cross it out like that. But what we can do is we can find the inverse matrix. And so this right here is called the inverse matrix, and it undoes A. And what essentially happens is these matrices cancel out, and then I have xy by itself, and there's my answer. xy equals A inverse times B. Now why is it here? Because everything I do on the left side of my equation, I also do on the right-hand side of my equation. So I multiplied on the left side by A inverse here, they canceled. I multiplied on the left side here by A inverse. Let's try this out in a calculator. So pull out your calculator, and you want to look for your matrix button. Now on a TI-84, it's right here, matrix. If you have an older calculator, sometimes right in here there's a matrix button where you don't have to hit second. All right, I'm going to start by going second matrix, and I'm going to first enter in matrix A for letter A. I go over to edit, press enter, and this is going to be a 2 by 2 matrix. So I enter the dimensions there, and it's going to match right down here. And I can do then 2, and I can keep pressing enter to go across. 2, 3, 4, 5. I've entered my matrix. I'm going to hit second quit. I now need matrix B. So I hit second matrix. I'm going to go down to matrix B. Oops, that is not what I wanted to do because I want to edit it. So second matrix, I go down to B and over to, okay, I go to edit and then down to B. This one has 2 rows and 1 column. I know I've done it right because I've got the right number of spaces. And then I put in, let's see, enter, 25, enter, 43. Enter. Okay, I've got those in. It looks just like the matrix over here. I hit second quit. And now here's the nifty part. I hit second matrix, and I choose A, but I want A inverse. See this x to the -1? That's going to give me A inverse. I can press enter if I just want to see what it is. So that's A inverse, the one that undoes A. But what I'm really interested in, let me hit second entry. Now I've got everything there. I want A inverse times, and now I'm going to hit second matrix, and I'm going to choose B. Press enter. So there's the equation I have right here, A inverse B. I press enter, and there's my answer. xy, whoops, I don't know why I put a fraction bar there. xy equals, and let's see, let's go back over here. There it was, 2, 7. xy equals 2, 7. And so there's our answer. It's the point 2, 7. Or we could write it like this. All right, so now let's try another one. Or actually, let's first look at what the steps are. So our steps in our problems are going to be 1, to rewrite the system using matrices, 2, to enter the matrices in our calculator, and last we're going to calculate A inverse B to get our answer. All right, so let's solve this system using matrices. The first step is to rewrite it using matrices. So I first need a matrix in here, and those numbers are going to go in exactly like they look: 10, -9, 3, and 15. Then right here I'm going to have x and y, and that's going to equal 179 and -141. All right, so we've done the first bit. Now this is matrix A, this is matrix B, and I go to my calculator. You might want to pause and try this out on your own, and then watch me do it. So I go to second matrix, I go over to edit, and I choose matrix A, and I'm going to put in those new numbers. So press enter. It's still a 2 by 2, so that looks the same. 10, enter, -9, enter, and just overwrites what was there before. 3, enter, 15, enter. Always good to make sure it looks the same. That looks good. Second, quit. Then I go to second matrix, and I go over to edit again, and now I choose B. It's still a 2 by 1. I'm going to put in 179, enter, -141, enter, second, quit, and now I'm just ready to go. Second matrix, I choose A inverse with this x to the -1, second matrix D. I press enter, and there's my answer. xy equals A inverse B, always in that order, by the way, and it equals, let's see, grab that answer, 8, -11. I'll just grab that over here. So this is what it looks like, and my answer is 8, -11. And we're ready to go on to our next one. Now we're going to jump this up to a 3 by 3. Now here's the thing. Nothing really changes. The only difference is all my coefficients aren't in a 2 by 2. They're in a 3 by 3. The number in front of x here is a 1, so I have 1, 5, 7. On the second row I have 2. This negative goes along, so it's -1, 5. And here I have 3, 3, and -3. And now my variables are x, y, z. You'll notice they were all in the same order, set up really nicely for us. So x, y, z. So we have x and y and z. And our other matrix is 43, 32, -15. All right, I'm going to get these in the calculator and meet you up, and you can pause as well. All right, here you're going to see that my matrix A, this time it's not 2 by 2, it's 3 by 3, and I've entered all the numbers in. And then I hit second, quit, and then we'll get our, that's our old answer. Then we'll go to second matrix, and we're going to go over to edit. We're going to choose choice B, and we're going to change that to a 3 by 1. We'll enter those numbers. All right, I've got those entered, 43, 32, and -15. Hit second, quit, and now I'm ready to do that multiplication. So second matrix, I grab A inverse. Second matrix, I grab matrix B, and there's my answer right there, 106, which means that the solution to this is that x equals 1, y equals 0, and z equals 6. All right, we're going to look at one last problem that looks a little different. You'll notice there's x and y, but there's x and z, and well, this one has x, y, and z. So we've got 3 variables, which means I'm going to need a 3 by 3 matrix. Now in this first one, when I look at x, y, I'm like, okay, in front of x I have a 1, in front of y, I have a 5. Well, what do you suppose is in front of z? Well, if it isn't there, it's a 0. I have 0 z's. I go to this next one. In front of x, I have a 3. There is no y, so that's going to be a 0. In front of z, I have 2. And then in this next one, in front of x, there's a 1. In front of y, there's a negative 1. In front of z, there's a negative 1. And then we again take this times x, y, z equals, and we have 45, 11, negative 1. And now you want to put this in for A and this in for B. And of course our answer is going to be found using A inverse B. I'm going to do it and come back with the answer. Pause until you've got the answer. All right, and here's my answer. I did A inverse B after entering in those matrices, and I get 5, 8, negative 2, which of course means that x equals 5, y equals 8, and z equals negative 2. And now we are ready for our homework, which is section 6.6, 35 through 45.